Yeah, I'm a plant person, geek, if you will. My wife tells me it's an addiction.
It is. She's right.
But I was hooked a long time ago. So it's something you build on. You don't learn it overnight. It takes a lot of years to really get into this. But the more you study plants, you can't stay out of the phytochemistry aspect of plants. It's just part of who they are. And so it's a very interesting topic. It's one that dates way back before humans were writing. And so it's a very old topic as well. It's also a very broad topic. So, well, that arrow button's not working. So yeah, I do plant identifications is one of the things other than research. And so I work in weed science, and you might wonder kind of why we do plant identifications in weed science. Identification is the key to control whatever you're going to do with it. If you don't know what it is, you don't have a positive ID, a lot of the other things you do are kind of irrelevant. And so yeah, I do a lot of weed IDs, but I do other IDs as well for people, and then some companies and stuff want IDs. So that's one of the things that I do other than research. Also, so when you're addicted to plants, you spend all your day and part of your nights working with them. And so I do collect plants as well. So I have a New World collection, all planted in the ground, that's behind the house. And then I'm just going to flip through some of this quickly, kind of give you sort of some background. Also have an Old World collection, it's all in front of the house. A lot of container things, 9 greenhouses. These are all xeric container plants in one of them. So a lot of biodiversity, a lot of phytochemistry in all of this. Desert plants definitely need to protect themselves, and they do. In the front of that one is Australian plants. So then another xeric house in the back. This is another xeric house in the front. The one on the top right is from Chile, which is called a sheep-eating plant. So there's a lot of interesting ecology with these plants in association with animals. I have a lot of African flora. So this is scattered in different greenhouses. The one on the left's in another house, but then I also have a house dedicated just to the African flora and some rare species in there. A lot of ethnobotanical plants in that one as well. And some tropical container plants, some unusual plants in that one. And then another tropical in-ground house, so you kind of see the pattern here. So a lot of citrus in this, as well as some other unusual plants. There's cardamom on the real right and snail tree on the left. And then another tropical in-ground house here. So a lot of different plants in there. It's a rare ginger on top right in Central America. And then another house here with a lot of musa in this one. And then some other odd things in that one. This is another Aristolochia. And then lastly, the newest one, have a lot of gingers in this one and so forth. So a lot of container plants. I have a lot of heirloom crops. So you get into the ethnobotany part of it. There's a lot of these plants date way back in human civilization. So heirloom corns, different types of cottons, a lot of legumes, snake gourd. So this is some old world things. This is new world. It's kind of new. This is a loofah species, similar to the peanut, but it's kind of old world version of it there. So and a lot of new plants coming all the time. So you can kind of see there's a lot of things that you can learn from plants, and I don't know everything about them, but I think today with the technology we have, it's remarkable what we can learn from plants. So in all that, yeah, I have a lot of ethnobotanical plants, and that's an interest of mine that long has. There's an example here. Some exotic species and New World species as well. So if you travel a lot, you go different places around the world or the United States, I think everywhere you go you'll see plants. There are very few places where you won't see plants. And so there are a lot of those places where humans have had interactions with those plants dating way back before we had records. And so, islands, wherever they may be, you're going to see a lot of variation in plants, different plant species. And so each, as he said, like humans, each plant has a story to tell. But it's a little difficult in many cases because we don't have any documentation of it. And now archaeology and a lot of that's kind of piecing some of it together. Eastern North America has a very rich history with ethnobotany. Got the islands. And then we have a whole range, thousands of introduced cultivated plants. And each one of those plants comes in sort of a whole story in itself. We have a lot of escaped species, and so a lot of those were ornamentals again. They escape, they get loose, so you have a lot of ecology and interactions there with those plants that may be a little bit new to this continent. Some have uses and some, very little. Actually much more troublesome than they are of value. So in the lecture tonight, I kind of want to go through a few things. We're going to kind of do an overview, but this is sort of the outline I drafted up there. We'll go through some definitions. You kind of can't get around definitions because I may use something you may kind of wonder what I'm talking about. So I'll just go through some things so you know what I'm referring to. We'll go through a little bit of the history, where we'll get into the term apothecary. We'll discuss some of that, kind of plants and humans there. And then we'll kind of go through some of the plants. We'll look at some of the chemistry of the different plants, kind of how they're bioactive in humans, maybe some other organisms besides humans. And then we'll go through, I'll make some closing remarks and things about some things that are kind of current that might be relevant to you today. I'll give you some resources. And then in the end, kind of think during all this, what plants you may have purchased recently and you brought home maybe a house plant or something like that. And we'll just kind of do maybe a few of those just for fun and kind of, we'll talk a little about the chemistry of those plants. Because sometimes you bring a plant home and you don't maybe not realize that, it was poisonous or it had these uses or that use or whatever. So anyway, there might be something of interest there. So on the definitions here, apothecary is almost equivalent to the term pharmacy. Okay, it's an old term, obviously, because we don't use it much today. Obviously, if I said pharmacy, you'd be very familiar with that term. So essentially, it's a Greek term, means a medicine. So that makes sense to you because if you go to a pharmacy, that's generally what you're getting. Phytochemistry, as the term implies, is plant chemistry. Okay, so that's sort of what we're talking about. We're going to focus in on some of the plant chemistry that's relevant to humans. There's a lot of plant chemistry that's more relevant to plants. We're going to look at more of that that's applicable to humans. Ethnobotany is a study of plant uses by people. Okay, so keep in mind, ethnobotany is a broad range. Okay, it doesn't include just medicinal plants. It includes plants that's used for other things, aerial poisons, all that kind of stuff. Okay, so those are ethnobotanical plants, but they're not going to fit within medicinal plants. Okay, so anyway, we'll cover some things like that as well. But herbalism is another term that's been around a long time, still used today. That's a study and use of medicinal properties of plants. You hear about herbalists and that kind of thing. And then, of course, medicinal plants are plants used for medicine. And there are quite a number. So I want to mention this here kind of as a little bit of a disclaimer, so you don't think I'm making recommendations. And so today in modern medicine, and we'll talk about where this kind of split too, because it's not always been the case where we had two disciplines like this, but you have the pharmacist, the PharmD, and then you have your medical doctor, your physician, okay? And so one gives you the prescription and the other one fills it. And so that's sort of how those two work in tandem. But so anyway, when you get into some of these plants, I'm not recommending you use them. Consult your physician, right? Before you go out and use some of these. And you'll kind of see why as we go through kind of the complexity of some of these things. And because humans tend to be kind of a heterozygous group, one responds different, okay, to the same medication. And so it's kind of difficult to make a recommendation by any means. So the story of plants and people began obviously thousands of years ago, beyond our recorded history. And we find that out more and more all the time. Archaeologists, they do digs and they find certain plants and things at different digs. And that predates what we know from recorded history. So there's a lot of terms, you've probably seen in literature, the medicine man. Actually had a movie about the medicine man with Sean Connery, which I'm not. And then you've heard of shaman, particularly in some of the third world countries and things. And then some people use the term witch doctor. I don't know what that is, but then you have herbalist. You still see herbalists around. Some people are called healers, and then you've got the apothecary term. And so we'll kind of go through that, and you kind of say, well, what about those? It's kind of odd, it's kind of a myth, right? The shaman. This plant's called Salandra, and they say that if you go into tropical America and you see this in front of somebody's house, it's a pretty good sign there's a shaman lives there. And so these, plants are still used in other parts of the country. Not like in the U.S. so much. So if we go back in documentation of ethnobotany, of just what we know from documents, from the clay tablets of the Sumerians about 5,000 years ago, there's records of humans using plants. So there's an ethnobotanical record. That's probably one of the earliest outside archaeological digs and those type things. India, about 1900 BC, written in Sanskrit, some documentation of humans using plants. And then a little bit more recent with the ancient Egypt's, Eber's Papyrus, 1550. So still dating a pretty good while back. That's BC, by the way. So it's a pretty long time ago. Then a little bit more recent with the Han Dynasty in China, 168 BC. Some recordings of them using plants in medicine. And we know in China, their use of medicinal plants goes way back. And so I'm pretty sure before 168 BC. And then in Japan with the Asuka, starting in 538 BC. And then the early Nara. Nara goes through 710, but in the early part of the Nara periods, pharmacists were really ranked higher than physicians. And so that, again, emphasis on the use of plants was pretty high in Japan at that time. And so at least in the emperor's house, pharmacists actually were put in higher standing than physicians. So we move up a little more recent with Baghdad. So in Baghdad, the first drugstores opened in 754. This is during the Islamic Golden Age. And then they expanded on that in the 8th and 9th centuries. And really were at a point where they were doing distillations and purifications of plant compounds. And so that was quite an advance in medicine. So in Europe, under Emperor Frederick II, so he, in 1240, split the professions of physicians and apothecaries. And so this is the first time we've seen those two separated. And so it's probably evidence that the science was growing, and so there was a lot of information for one discipline. And then we still see this today, right, with pharmacists and physicians in separate professions. And so it all started in 1240 AD, and then we see the first apothecary opening in Trier, Germany in 1241. And some of those apothecaries are still open today in Europe. Not many of them, but so that dates way back, that practice. So I want to mention here a little bit about botanic gardens and medicine. So the first botanic garden was opened in Europe, in Italy, in 1543, okay? So a lot of the botanic gardens at that time were really opened in conjunction with medical schools, okay? Because they had the plants there, they studied the plants for use in the apothecaries, and so you might have a botanist that would kind of manage the garden, those type things, but it would be closely affiliated with the medical school, okay? Then Carl Linnaeus, Carl von Linnaeus, he is considered the father of modern botany. So he was actually a professor of medicine. So a lot of people are familiar with his work describing plants, but actually he had a degree in medicine. He worked at Uppsala University, and in 1750 he was put in charge of the Botanic Garden, and he actually taught class in the Botanic Garden at times. Okay? And in 1753 he published Species Plantarum. okay? And in this, he consistently used the binomial system of classification, okay? And so that led precedence today to what we use in all Latin names, okay? So you have a scientific name, you have a common name. So the scientific names, this is the beginning of all of that. And so he goes way back. But if you look at a lot of the plants he named, if you see officinale, officinalis, or officinarum, you'll see an L behind it, okay? And that denotes, that's an abbreviation for Linnaeus. So that's one that he named, okay? And so what that means is with uses in medicine or herbalism, the official herb, okay? So those were plants being used in European shops at the time when he identified and described that species in that text. So it's kind of interesting. He was the only one that really did that. So if you see that in the epithet of a scientific name, that's what that means. And that'll let you kind of know a little bit about the history of that plant with regard to the apothecary in Europe in the 1700s. So if we move over to the U.S., the first known botanic garden was John Bartram, 1728, and he was a botanist, okay? And he would probably have medicinal plants along with a lot of the other plants that he had in that garden at the time. And then in 1820, there was this idea to have a national botanic garden. And you notice here, contribute to the welfare of the American people. So again, this concept of ethnobotany, plants that have some use to humans. So phytochemistry, is still being studied. It's utilized the world over. It's a very big science because it doesn't just take a lot of things that we use. There's a lot of other things, a lot of new things. And we get into chemistry, we'll kind of talk about that. So if we look currently, according to the WHO, that's the World Health Organization, 80% of the people in some Asian African countries still use herbal medicines, okay? So the doctor to patient ratio, you may have a doctor per thousands of patients, okay? And so when you get into that kind of a situation, they're probably going to go somewhere else, okay? And that somewhere else would be herbal medicines. So it's still very important to a lot of cultures around the world. Of the 122 compounds, this is in 2001, in modern medicine, 80% of those had identical or similar uses to ethnobotany, okay? So we still see that today. A lot of the chemical compounds that are being isolated and characterized are actually from plants that have some known ethnobotanical use. And they're just trying to validate that use. So if they can find a chemical, they can repeat that, then they've identified what the active ingredient is. So still a lot of the new chemistry that's going on deals with that. So to date, at least 12,000 compounds have been identified, but that's only an estimated 10% of what actually exists. So there's really a lot more area to be covered with regard to drug discovery. And this is kind of evident, this demand issue with regard to the dietary supplement market. So we're looking at U.S. domestic of 132.8 billion globally. That's what we're looking at currently. That's at 2016. Their projection for 2022 was 220.3 billion. Okay, 8.8% growth. That's faster than human growth, right? We're probably 2.5 somewhere in there. So that's exceeding our growth rate. So yeah, that indicates kind of an increasing demand for these products. So we're talking about things like this, dietary supplements, so herbal medicines in a jar that you can buy over the counter. So what makes plants biologically active for humans? So that would be the phytochemistry. So every day in the plant world, there's something going on called biological warfare, okay? So plants have to deal with a whole host of combatants, all right? So they're dealing with insects. That's pretty obvious, right? You have any kind of garden or work with plants, you'll know insects attack them. Bacteria, you have bacterial diseases, right? Viruses, viral diseases. We don't have much cure for viral. A lot of times we use resistance, have to breed it out. Fungi, fungal diseases. Sometimes just the environment, harsh environment, okay? Intense light, whatever it may be. Drought, whatever it may be. Protozoa, possibly another one. Plants, right? They got to compete with other plants, all right? We often call that allelopathy, okay, where they produce chemicals that suppress surrounding plants. Mollusk, snails, those type organisms, right? Yeah, they attack plants. And then obviously herbivores, plants, are eaten by animals, okay? Including humans. So what attacks humans? The exact same problems plants have, right? So it makes sense that if we consume what the plant's using for defense, it might work similar in humans, okay? It's probably a little more applicable topical, okay, which would be on the surface, on your skin, something like that, okay? So when it gets inside the human body, sometimes it's a little bit different. And we'll get into chemistry a little bit more, okay? But this sort of explains why we do have some commonalities between plants and why some of that chemistry works in humans the way it does. Before I get into some of the chemical compounds, I want to mention this because this is something that when you go down and you get a prescription, that's an isolated, purified form, FDA approved, okay? And so it is very well known. It's been very highly studied, okay, before they'll approve it. But when you're consuming plant parts, it's a little bit different. You have a lot of different chemistry within that plant, okay? And so each one of those compounds may react a little different, okay, when we consume it. So there is that multifunctionality issue with plants. So this is ginger. This is one y'all should be familiar with. You go down to the grocer, whatever, you're going to see, this is white ginger. And so you can see the rhizomes there on the surface of the container. So you take that home. If you look at the chemistry of that plant, it's going to vary a little bit, right? So you're going to have your carbs, fats, vitamins, minerals. It's pretty typical for a lot of plants we consume. But if you look at the active principles, okay? So if you look at gingerol, anti-cancer, anti-tumor, anti-leukemia, anti-arthritic, okay? But then you look at gingerone, antidiarrheal, antioxidant, anti-inflammatory. So look at the cooking aspect of it. As you heat gingerol, it is converted to gingerone. So just by cooking that, you change the bioactivity of that plant, okay? So that's just one example, okay? Sometimes you consume a plant, we'll see it a little bit when we get into chemistry, and actually the different compounds do different things, okay? In this case, the compound changes and it does different things, okay? So keep that in mind as we go through here, because there's a lot of different chemistry. With regard to gingers, there's a lot of species that are recently identified. We don't know what the chemistry of those are yet at this point. This was identified in China in 2012, so still a fairly recent species to our knowledge. So we're going to look at 4 major biochemical classes, okay? And these are bioactive classes. So we have our alkaloids, okay? Glycosides, polyphenols, and terpenes. And there are different ways of looking at these compounds. We can look at them strictly from a chemical standpoint, okay? Which those are the chemical names on the left there, all right? And the chemical structure there on the right. And that's the genera they occur in. Or we can look at them from a biological activity standpoint, okay? And so you can see they're antimalarial, et cetera, okay? So we're going to kind of fuse those together. I want to focus a little more, look at the plant, and then we'll talk about kind of what's in the plant and how it is bioactive. I want to mention this because some plants that we use, like for heart medicine or so some of them have a fairly narrow therapeutic index, and so I'll explain this a little bit because I'll mention it as I go through a little bit with some of these more toxic compounds, anti-cancer drugs, those type things. You kind of wonder why you get sick when you take an anti-cancer drug. This will kind of help explain it a little bit. But so you got your toxic dose and you got your effective dose. You want your toxic dose to be, it's going to take a lot of plant material, okay, to be toxic, all right? And so what that does is that makes that therapeutic index value much higher, okay? But as that gets very narrow, if it takes very little bit to be toxic, that narrows that way down. And so your effective dose, then you get a little issue there with potential overdose, okay? And so So we see that with some compounds, and that a lot of the research you'll see actually looks at that pretty closely, particularly with some of the toxic compounds. They can be very effective for heart medications or cancer, whatever it might be, but they have to really watch that, because sometimes you get an LD50s and you get a little accumulation, and then you get a little bit overdosed on some of it. And some of these can have some pretty serious side effects. So anyway, I want to mention that therapeutic index. We might mention as we get to some of the more toxic compounds that are used in medicine. So this is berberine. And you'll see on the left there, I mentioned some things that, some activities it has. If I have a question mark on that, if I don't talk about it, if it has a question mark on that, it's probably, it's a little bit unclear exactly if that is the case. A lot of this is done in test mice, that kind of thing. And so they don't know exactly how it's going to react in humans. But it kind of gives them an idea of some potential for the different compounds. And so alkaloids can be fairly complex. They're called alkaloids because they're alkaline in solution, okay? And so if you look through these compounds, they're going to be quite different in appearance, okay? So it has to do more with the pH than it does in some ways the chemistry. And so there's some very powerful medicines within this group. Berberine is yellow in color. And so you'll see in the root here, you'll see the yellow color. And golden seal, by the way, also is in this group. All right, so, and it's still sold for medicine today, wild harvested and collected. The other thing about alkaloids, a lot of times they're very complex, and so they're hard to synthesize in a lab. It's not like Tylenol or aspirin, one of those. It's a little more hard to synthesize, and so a lot of them would be wild collected, wild harvested, and utilized for medicine. So anyway, it has a number of different things, but the thing I want to point out here is the antibiotics, okay? So we see more and more drug-resistant bacteria, right? Staphylococcus aureus would be one of those, okay? And so we're seeing more and more of that. And so there's a lot of science going on right now trying to look at alternatives, okay? Some plant-based antibiotics, and kind of get away from penicillin and some of its derivatives for antibiotics. And so that's one of the things they've been looking at with berberine, which has some pretty good activity on Staphylococcus aureus, which is one of the major ones that has some resistance. But it is fairly complicated, and so it would probably have to be wild collected. But it does give some potential there. Anti-asthma and ephedra. This is one that got a lot of news. FDA pulled, you remember, had a lot of health issues with it back early on. This is the one from China. This is Seneca. So it comes from ephedra. Mormon tea is an ephedra species, so out west they would drink the tea, and so fairly small molecule on this one. This has been around a long time. This is Vinca minor, so it's a pretty common ornamental. It doesn't do well here in the south like Vinca major, and so I mean I have it at the house, but you don't see it commonly like the other one. But it contains vincamine. Okay, and vincamine is a vasodilator. So vasodilators, they kind of increase the flow of blood, the volume of blood, but they also lower your blood pressure. So, and you can see there, fairly complicated compound on that one. There's a lot of science now with regard to anti-cancer, anti-tumor drugs, that kind of thing, anti-leukemic drugs. This is one of those cases here. So this is cephalotaxis. So this is, and this is Harringtonii, which you can see a lot of the compounds are actually named after the genus they were isolated from. And so Homo harringtonii. And so you can see a very complicated molecule on this one right here. And so this is related to Taxus. Remember, Taxus is where they get Taxol, which is a fairly new compound they use as an anti-tumor drug. This is another one. This one's been around a long time, isolated back in the 60s. In the case of vincristine, it's usually sold in sulfate form. Wouldn't be available to you and I, but except in a whole plant form. But in purified form, it's something doctors might use in the case of leukemia. It's used a lot in a case with childhood leukemia, with some rates about 90% remission rate, so it's fairly high. But it's a fairly complicated molecule. The top one is vincristine, and the bottom one here has been vinblastine. And so if you look at, this is really the deal on some of these, they're in the plant in very small, minute amounts. And you've heard that with Taxol, right? Because they're wiping out all the white cedar. But a lot of these are very small amounts. It takes a lot of plant material to get, a small amount. The dosage is pretty small though, fortunately, but so you're looking at, 20 milligrams of vincristine from a ton of plant material. So that's a lot of plant material, isn't it? Okay? But it's usually given like 1 milligram doses. So it's a fairly small rate, but it still takes a lot of plant material, okay? And so that kind of makes the chemotherapy a little bit pricey, but you can see why that would be difficult to, synthetically produce that compound. Piperine, so these are pipers, examples of pipers. Pipers occur New and Old World, it's a fairly large genus. That's black pepper on the right, which is where we get the peppercorns that we use in culinary. So it has that kind of strong flavor to it. And so, anti-hyperglycemic. So in the case of people who may be diabetic, that might have some applications. Stimulants. About 90% of Americans use some type of stimulant on a regular basis. Okay? And when I mention the plants, you'll recognize, oh yeah, I use that. So, but not the first one, right? Cocaine. So really cocaine is probably about 1, maybe 2% of the population use that type of barbiturate type, stimulants. And so it's fairly low, if you say 90%. So 1% is pretty small compared to caffeine, nicotine, and theobromine. So this is coffee. Obviously, it has caffeine unless you're drinking decaf. Also in tea, unless it's decaffeinated. So a lot of these are actually deterrents for herbivory. So they're bitter and they're designed to deter animals from feeding on them. So as you might expect, there is an LD50 on those as well. And so you can get a little bit too much of some of those. An LD50 on that one there happens to be 150 to 200 milligrams per kilogram. So you can't get too much caffeine. And they have warned people about drinking too many Red Bulls and those kinds of things. And that's why. Nicotine is another stimulant. And you can see this is the lethal dose here, so not the LD50. It's not 50% of the population, it's the whole population there. 30 to 60 milligrams, okay? So you can, and it can be absorbed through the skin, so you can get it different ways. And that's sacred tobacco there. That's a different species of Nicotiana. About 50 species, New World, and they date way back in human history. So and you can see where it might be absorbed in the skin. Fairly small molecule, okay? And of course my favorite, this is theobromine from theobromocacao, which is chocolate. Most of it's a neotropical tree, but most of it's produced in tropical Africa today. And around the world, tons of chocolate's consumed. So very common compound. Some things that are a little bit toxic that might be of interest to you, some things that you may actually encounter. Atropine, and so some of you wear glasses, so you may be familiar with atropine. It's produced mainly by solanaceous plants. You'll notice here the LD50 there, 453 milligrams per person, okay, not per kilogram. There's a look at the molecule up there at the top. So as you can see, it's fairly small, right? So what we have here is datura on the left, sometimes known as ornamental angels, trumpets. That's Brugmansia on the right, okay, another one. So that one's Old and New World. This one here is just New World on the Brugmansia. And so it's been used way back in South America. But these can be absorbed, like scopolamine can be absorbed through the skin, okay? So if you handle the plant, excessively, the first symptom's going to be what? Sensitivity to light, okay? It dilates your pupils, okay? And it's the same reason that eye doctors use it, okay? Dilate your pupils. And so then it gets into some worse symptoms after that if you get too much. But it's kind of an interesting group of plants, and it has a long, rich ethnobotanical history because of that. So another toxin, tubercularine. I thought I'd kind of mention this because we talk about ethnobotany. This is one of the arrow poisons. And so we think, oh, you know, we would never want to use an arrow poison, right? But they're cardiac alkaloids, so they're active upon the heart. And so they do have some potential in medicine. But it gets back to that therapeutic index I mentioned earlier. If you look at the LD50 there for mice and rabbits, I left a B out of that, 0.13 milligrams per kilogram. Very, very small amount, okay? And so, you know, it may be some pretty good medicine, but it's going to have to be really, really carefully monitored. So it's something probably you'd only get in the hospital while you're in the hospital. This is another interesting one that's been around a long time. And of course, they used to use strychnine as a rodenticide, but it's also been used as an arrow poison, okay? And its activity is different, okay? It's a neurotoxin. And so this was studied in the mid-1900s by chemists, and they were, chemists are still perplexed a bit by it today. It's a very large molecule, but it's a neurotoxin. And so, but if you look at the LD50 on that oral, 0.5 milligrams per kilogram. It's very, very toxic, okay? And it's produced by strychnos, the genus strychnos, Nux vomica, the one in Africa. There's another one, toxica, which occurs in neotropics, which is used for arrow poison there. So, so the tubercularian is made from different plants in tropical America, okay? So not just the species we mentioned, but it's made from different plants. Depending on what plant it is, it can be more or less toxic. But they're more effective on the heart. These here would be more of a neurotoxin here, so the activity is a little bit different. Glycosides, the first group here is cyanogenic glycosides. So if this is Durin, as you're looking at there, and so we'll look at these kind of briefly and kind of go through them. So here's Durin, first identified in 1906 as responsible for killing cattle. And so I wished I had a pointer, but you can see in the middle at the bottom, see that carbon with the triple bond nitrogen? So when that breaks loose, what do you think that is? It's called prussic acid, but it has another name, cyanide, okay? And so when it gets in the acidic stomach of us or animals, that will be cleaved off, okay? And that becomes very toxic, obviously, right? And this is one of the groups of chemicals that actually cause sudden death in livestock, for example. So they're fairly toxic. Some things that we might encounter, bitter almonds, which we assume all the almonds we eat are not bitter almonds, they're sweet almonds. And peach seed is another one. Remember to say not to eat the peach seed, that's why. It has amygdalin, and you can see the cyanide right there, okay, ready to be cleaved off. It's not cyanide at this point, okay, it's amygdalin. But once that gets in the stomach, it'd be cleaved off, and you would have cyanide. Cyanogenic glycosides here with cassava. Cassava kills more people than any other plant, okay? You have bitter cassava and sweet cassava. Bitter cassava is very, very dangerous. And look up here at the top right, you can see the nitrogen, okay? Triple bond the carbon, that would be cleaved off, and that would cause major problems, okay? So we have some cyanogenic glycosides that can be produced in clovers, for example. They also produce coumarins, which is a blood thinner. It's another issue that animals can run into, and people as well. This is one that's been around for a long time, still used in heart medicine today. This is Dija, and really one of the major ones that's used is this digoxin. And so I gave you the LD50 on that for rats. There's a daily dose, okay? It has a 36-hour half-life, and so you can see how it might accumulate a little bit, but it has a little better therapeutic window than some of the other things that we've looked at, okay? But this is one that's been around a long time. This one's one that'd be back in the European shops back in the old days. And so it's been around a long time as a heart medication. And you can see how complex it is. So again, this is another one that would be, naturally harvested and purified. And there's about 63 glycosides in digitalis, by the way. So not just that one, there's a whole myriad of them. And some people say when you take a plant in whole form, it's a little bit safer because you get a little bit more buffering from other compounds. not recommending that, but yeah, there's a lot more in those plants that are related to that one particular compound they isolate. This is calotropin. This is another arrow poison. This one's African and Asian in origin. And so LD50 on that one, 0.1 milligrams per kilogram. Okay? And this is one of them cardiac glycosides, so it's active upon the heart. So when you see hunters with the arrows and stuff, with the plains animals and all, that's one they would be using. And it's a very complicated molecule on that one as well. I just want to do the arrow poison thing, kind of give you an idea of how they compare. This is interperitoneal, so this is the peritoneum, so this is the lower stomach, okay? And so if the arrow went through, okay, into the stomach cavity and the toxins released, okay, that's kind of how these would be comparable, okay? So they're all on kind of apples to apples basis here. And so if we look at calotropin, which we just talked about, it's a glycoside, okay? And it's a cardiac glycoside, see the C at the end, okay? 9.2 milligrams per kilogram. Strychnine, okay, it's an alkaloid, okay? Neurotoxin, 0.98. Very little, okay? Milligrams per kilogram. Tubicararine, 0.42 milligrams per kilogram. IV is 0.097. So intravenous, very, very lethal, okay? So that kind of gives you an idea how the arrow poisons, some people say, well, this one's more lethal than that one or whatever. But if you put them apples to apples, you kind of get an idea which ones. But then keep in mind, you know, kind of where they have to hit the animal there to get that exact reaction. So we'll quickly kind of go through some polyphenols. So flavonoids are in this group of polyphenols. You've heard a lot of things about flavonoids lately. A whole host of bioactive principles in those. I won't get into a lot of that. That at the top left chemical there, that's a phenol. Okay, so polyphenols, a whole bunch of those together. There's one on the right. The one at the bottom there is tannin. So if there's any reason to consume a plant, this would be it. Okay, tannins. And I say tannins because they're different depending on, there's a class of compounds that are tannins. But tannins are astringent. Okay, witch hazel. So anybody familiar with witch hazel? You put it on your skin, it draws the skin up, so it closes the wound, all right? Used for healing, right? And in the same way, internally, for internal bleeding, those kinds of things, a lot of times they use tannin. The other thing about tannins is they precipitate alkaloids. So right after you consume a toxic alkaloid, if they ingest you with tannins, they have a tendency to precipitate. So it's used sometimes as an antidote for alkaloid poisoning, okay? But it will also precipitate proteins. So you have to be careful how many tannins you intake, okay? But they're in plants. They're one of the last pigments to leave. They're water soluble. So when you eat a plant, even though it's green, you're consuming tannins with all the other stuff that comes with it, okay? Tannins is responsible, tannic acid, so when it gets into water, all right, it kind of changes the color of the water. That's from the pigment of the tannin, okay? So it has a color to it. And you can see the leaves there, last pigment there, it's in the leaves, tannin. So it's a polyphenol, and you can see how complex, and fairly reactive too, okay? Another group, the catechins, and so there's and flavonols, so you can see that basic backbone up there. So a lot of different uses, and some not quite conclusive, okay? Like blood circulation, cholesterol, those kinds of things. But you can get too much on those. And so again, chocolate is a source of that. Tea is another source of catechins. And so a lot of times we intake catechins and we really don't realize that we're taking them. But there is some potential there, some health benefits. Terpenes, I'll quickly go through. There's a lot of terpenes in plants. And they have a whole range of activity when they're consumed. So we have the monoterpenes. This is the basic class. You got two isopyrenes put together. That's a basic monoterpene, okay, with the chemistry. And so there's a whole host of those. Iridoids is one that a lot of people are looking at right now because they have a fairly good range of bioactive compounds that seem to be good for human health. Limonene, which is a pretty common one, it's a basic one, has a number of uses on it. Obviously comes from citrus among some other plants. Myrcene, which is another one from hops. And this one here has some isomers, but this one here typically we see in lavender. Pinene, principal ingredient in turpentine. Then we have some sesquiterpenes, a number of those, fairly complicated there. They think maybe anti-inflammatory on that one. It occurs in hops. So you see a lot of studies around beer and all that, whether it's good for you or it's not good for you and all that kind of stuff. It's not always easy to pin some of these down. Farnesene occurs in apples, kind of has that apple scent to it. Unfortunately, it's what attracts insects to the apple as well. So they've sort of figured out. Farnesol, so you got that OH alcohol group on the end there, and so lemongrass on that one. Diterpenes, so these are a little bit interesting here because we get back into the coffee issue here. So you got cafestol and caviol. So you got some different uses, not quite conclusive on cafestol there. But the interesting thing is that if you filter your coffee, you filter these out. And they've done studies with people who drink filtered coffee versus unfiltered coffee, and they think that the people who drink unfiltered coffee seem to have better health. And so, you know, be that as it may be, but yeah, keep in mind if you filter your coffee, you're filtering those two out. So that might not be as much benefit. And that's a look at them there. Look at the compounds, fairly complicated there. That's coffee in the image. I mentioned this one earlier, taxodiene. This is actually a precursor to Taxol, which is the anti-cancer, anti-tumor drug. And so you can see the taxodiene at the top, and then you can see the Taxol at the bottom. So you can certainly see that complex on the right, which is the taxodiene, okay? So it is that precursor. So that one there is used in chemotherapy. Rhabdosin is another one. This is from a mint, antioxidant, anti-cancer. Another one, fairly complicated molecule. That one's from Asia in origin there. So some tetraterpenes, we're getting into some more complexity, but these are some you'd be familiar with. Of course, you recognize carrots, tomatoes. I didn't put a tomato up there because you know what that was, right? Everybody knows pretty much that tomatoes have lycopene, but they are supposed to support certain health aspects. Look how long it is, a fairly long chain. But that one there is actually Eleagnus, so common ornamental with the red fruit, and so it has lycopene in it as well. And they have looked at it as a commercial production and all that. But the one here on the right is fairly interesting. So this is carrot. Everybody's familiar with the carrot, or familiar with carotene, right? You got alpha and beta carotenes. But if you split at that center double bond, you split that compound apart into two. That compound directly above it is retinol. Okay? So, for your eyes. The interesting thing about this is if you look at it, that long hydrocarbon chain, okay, it's not very soluble, okay? And so it tends to be stored in fat in the body. So if you clean a chicken and you look at the fat, that yellow color, that's carotene, okay? The body stores it. So the fat-soluble vitamins are what? A, K, E, and D. Vitamin A, retinol, okay? And so that's sort of why, if you look at that compound. But again, it is important for eyesight. And it is photoactive in carrots. Actually, it's used as part of that pathway with chlorophyll. And so you don't just see it in the roots, you see it in other parts of the plant. It is also photoreactive in our eyes, right? When it's retinol. So it's kind of interesting. I don't know how that all worked out between the two of those, but. And then we have the polyterpenes, which are long chains, particularly in the case of natural rubber. So huge chains. And then they come with vulcanization. They put a sulfur in there and they kind of fuse all that together, which is why they can't go back and reheat and reuse rubber so easily. That chain is really fixed pretty tightly when they do vulcanization. But there are other plants that have rubber type terpenes in them. There's two of them here. The one in the front is actually from Madagascar. It's also used as arrow poison, so you get some other things in with the rubber sometimes that aren't quite as desirable. And then camphor is another one, antibiotic, has a whole host of, and it's fairly complicated if you look at it there, but anyway, that's another one there. So I'll quickly kind of go through these. This is the acids, aristolochic acid. Used to be widely used at one time, now kind of fallen out of favor. It's used for snake bite and other things as well around the world. It's a fairly large genus that occurs here and other places as well. Fairly complicated molecule, but it can cause abortion, other things. So it does have some side effects and it is fairly toxic. Lectins, y'all are familiar with this one? Ricin. So this is water soluble, and the water soluble fraction. You have castor oil, which is the oil soluble, right? And people, used to castor oil, but it's not that favorable anymore as a laxative. But it comes from ricinus, and ricinus is an African genus. It gets about 40 feet tall over there. But in the seed, you have this compound called ricin. This is the LD, okay? Lethal dose, not LD50. This is estimated, okay? It's hard to find test subjects when you're doing these things. 1 milligrams per kilogram is what the speculation is, okay? So this is why when they get white powder on letters in DC or whatever, they get kind of alarmed. And it can also be absorbed through the skin, okay? So anyway, it's actually a phytolectin or a protein, okay? So it's going to look quite different than some of the other things that we've looked at. But it is a plant compound, it is a defense compound to protect that seed, right? So it can germinate and carry on next generation. And this is in Euphorbiaceae. Euphorbiaceae is well known for having some pretty toxic compounds. Pyrrolizidines, in particular we call these a lot of times pyrrolizidine alkaloids, but you can see the pyro group, okay? And this is retinosine, which occurs in comfrey. So there's about 660 of these compounds that's been isolated and identified, characterized so far, all right? And so in about 6,000 species. So they speculate that there's about 3% of all flowering plants that have pyrrolizidines, okay? So pyrrolizidines are hepatotoxic, so they cause liver failure, okay, if you get enough of them. And I've had people send in IDs and say, well, I've been eating this, it looks like, mustard greens or something like that, and it would turn out to be one of these plants that had pyrrolizidines in it. So again, ID is really critical before you start eating things. And this is a classic example. Cynoglossum fichinelle. Got a fichinelle named by Linnaeus, was used in the shops back in the 1700s. Nobody really realized it. Recent study indicates that it contains pyrrolizidine alkaloids, and they recommended cease using it. Okay, so some people might have gotten some side effects, maybe not documented, maybe it was. But again, comfrey, long used as a medicine. Who would have guessed? But it does occur a lot in Braginaceae. That's what family this one's in, okay? So sometimes if you look at family associations, sometimes the chemistry associations can be pretty similar. Quinones, a lot of different quinones. Some of these you'll be familiar with, antitumors, the Maben, juglone, from juglans. Some of these synthesides used all over the world. So that was the quinone backbone right there, the double auxins. This is a purgative. You see it in the New World, Old World planted, not so much in the U.S., but in some of those third world countries. Very complicated molecule, but widely used. And it's a senna, which you can see the name is Sinnalata, and so you can see the synthesides. This one here comes from the salvia, and again, we have about 1,000 species of salvia. There's a lot of chemistry there that we really haven't looked at. And so this is one of the compounds, and we're going to talk about another compound in the same plant has different chemistry, and it's going to be tannins. So just quickly go through here. Coffee weed, common weed there in row crops, has a Maben in it. This is juglone, which is antifungal, has a bunch of other properties other than antitumor. And tannins, so salvia, miltiorhiza. It's tannanone, and you notice tannanone also has another activity as well when it's consumed. Same plant, 2 different compounds, 3 different activities. Saponins, kind of the last group here we'll go through. Soap, piscicidal, antifungal, antibacterial, whole host of things. And sometimes we'll call them glycosidic or alkaloid, and I'll mention that. Obviously, if it's alkaloid, it's going to be a little bit alkaline. But they're called saponins. If you look at that, it's amphipathic. So you have 2 different sides of that compound. And so much like soaps would. So here's a list of some different things here. And that one there is a glycosidic, so you see the sugars attached to one side of that. Okay? So,
Yeah, there you go.
yeah. So you got three sugar molecules on that, so that one there is obviously, and that one there happens to be fairly toxic. So saponaria, so a lot of these were used for soaps way back before we kind of modernized soap. Sapindus, probably not so much sugar maple, more the red maple on that. We do know of red maple poisoning. Aesculus is well known to be poisonous. This is an interesting one here. It's called immortality herb, but it contains a saponin as well, and a fairly complicated one as well. It's in the cucurbitaceae. So capenicides, and then we have the ginsenicides from ginseng, which a lot of people take ginseng. And then we got soapweed, yucca, long used by Native Americans as a soap. A lot of these are piscicidal. They would lather them up, put them in the water, and they would stupefy or kill the fish, and then they would pick the fish off the surface of the water. A lot of places today it's illegal. Okay, so back to this. Focus a little bit here for a minute on drug discovery. So we know we have some pretty potent anti-cancer drugs, some potential antibiotics from plant compounds. This is camptothecin, which is still used, marketed under these 2 compounds at the bottom here. Fairly complicated, so it has to be isolated from the plant with some modification in the lab. But that's Camptotheca acuminata. That's an old world species. We have some other ones. This one's 40 times more potent than Tylenol, acetaminophen, and so fairly potent. The problem is that some of these compounds can't be synthesized in the lab like we do, okay, with acetaminophen, aspirin, all that, okay? So you get into some cost issues. Even though they have potential, they may not make it to the market. Another thing in drug discovery, we have a lot of species that are very rare. So actually collecting those, and I've gotten into this working with School of Pharmacy in the past. So it's kind of difficult to collect and do your drug analysis and stuff on that when you get into populations that's pretty small, okay? And so there may be some issues where we may never know what some of these plants actually have. This is echinacea, and so Echinex, one of those over-the-counter things that's sold in a bottle as an alterative in the winter. It's typically when people take it. So that's sort of in that group. So we may not know what those are. The other thing is we have a lot of horticulture varieties of that, and we don't know what the chemistry of those are. If it's better, whatever. We don't know. I will mention this with regard to Echinex. Actually, I co-authored on a paper that got the 2016 award as the most innovative paper. And so what we did in here was we wild collected some Echinacea purpurea, which is where they typically get the compound. And so what we discovered was that the microorganisms on the root surface is actually responsible for the bioactivity when people consume it. And so that opened up a whole new can of worms, and it sort of validated the discrepancies in previous research. They couldn't seem to quite figure out what the activity was, and that sort of explained a little bit because it wasn't really the plant itself, it was actually the microbes on the exterior of the root. And that really goes back into the horticultural plants. If you got the soil, potting media may not have the same host of organisms as you would in the wild. And so those are still some things out there that need a lot more work. Ginseng's another one that probably needs a lot of work as well in this area. So that brings me to conservation issues. A lot of these are becoming increasingly rare. Some of them are already rare. Podophyllum momodii, which originally where we got it, podophyllitoxin, which is an anti-tumor drug. It today is on sites, so it's protected under international law. And so it's getting harder and harder to obtain those type materials. We did a study over the entire eastern U.S. looking at our native podophyllum. It's not rare here. It is rare in Florida and some other states on the fringe. But at some point we may have some issues with it. Golden seal's already been rare in a number of states, okay? Ginseng obviously is. So there's a number of those things. The plant there on the bottom right is another anti-tumor drug, occurs only in Turkey. So it's a very, very, very small, in fact it's listed also as vulnerable. And then lady slipper root, which has never been really that common. So we tie that in with, we're at 7.6 billion people today, and then 2037 at 9 billion. So there's going to be increased pressure upon a lot of these wild populations that we can't synthesize in a lab at this point. So there are going to be some conservation issues coming down the road, I think, more and more. Dietary supplements, I mentioned the increase in all of these. Obviously, you need to consult your physician if you're going to plan on using those. A lot of people use these as opposed to going out wild harvesting and all that, okay? And so they can go down here. This is black cohosh, okay? And so people can go down and collect it. I will mention that there are other plants that look like black cohosh, and there have been some issues with contamination in some of these dietary supplements. So just a precaution on that. I will mention that the School of Pharmacy did a study on ginseng that was sold over the counter like this, and some of those had no ginseng at all in them, okay? And others were, you know, pretty reasonable. So that's another issue with some of the dietary supplements. So keep that in, you know, keep that in mind. It may be a placebo. The other thing too, identification. You know, if you're going to do wild collecting, you better make sure you identify it right. Again, we don't know. I mentioned this, it's a soil issue. We're cultivating things. It may not be exactly the same as what you're going to, you know, receive from a wild form. It's the case with ginseng. That's why the wild is so much more, you know, expensive than the domesticated. And then, of course, this is Virginia creeper on the left and poison ivy on the right. So, you know, make sure you don't make that mistake. Resources, there's some really good resources out there. I have this ethnobotany desk reference. Has them listed by scientific name, big, thick set. I mean, there's a lot of information in that book. Then there's a book not too old, Native American Ethnobotany. Has them listed 3 different ways, listed by tribe. It's listed by the mode of the action in it, the bioactivity, and it has it listed by the genus of the plant, okay? So it's a very good reference on Native American ethnobotany. Internet, unbelievable. I mean, there's new chemicals discovered all the time. I mean, you can go on there and run a search on something, and I mean, it's amazing. You got to know what you're looking for, but I mean, you can find a lot of information on the web. So, I put Johnny Jump Up in parentheses because there actually is a plant called Johnny Jump Up. So, anybody brought any plants home recently? Maybe a house plant or something? Nobody brought it? What? What was it?
No, I brought plants in from my garden.
Okay. I was looking for somebody may have had a house plant or something they brought in the house and...
You know what a money tree is?
What?
You ever heard of a money tree?
A money tree?
Yeah. They're sold in Chinese, in Asian stores. It's got a twisted root, it's got a twisted bark.
Yeah. You know what the genus is, or? Okay.
I can't remember what
We do Latin
it's the
names.
one that they braid. You know what I mean?
It's not Thai, though.
It's the lucky bamboo, and then they also do the braided one. It's got thick compound leaf.
Picura.
Oh, the Picara aquatica? Oh, yeah. Bombaceae, which I think that that family has actually kind of been merged with another family, but yeah, that's it's a large family. In fact, that's a aquatica that grows in the Amazon rainforest, and it has buttressing. So if you notice, if you grow them by themselves, you'll notice it'll start to form a buttress on it. And it has that kind of digitate leaf on it. So the woven looks very different than they do in the wild. But yeah, it's an Amazon rainforest tree. They have huge flowers on them, and cape oak is in the same group. and it's an emergent in the Amazon, but it occurs Old World as well. And they use the silk cotton for like pillows and things like that in batting, essentially. But they also make plywood out of it. But it's an emergent, so if you fly over the Amazon, you see these big giant trees sticking out of the forest, that's Ceiba pentandra, the Bombaceae. So they're an interesting group of plants.
I bought a moringa, M-O-R-I-N-G-A tree. I picked it up at a plant nursery. I'm really not sure of its origin.
Right.
I know it has some herbal.
It does. It does, yeah. Moringa oleifera. That's an Old World plant. Yeah, they eat the leaves. I mean, it has a big long pod on it when it produces a fruit. Little white.
Like dry climates or moist climates?
It's probably a little more dry. It's one that I have to bring in the house. I don't really put in the greenhouse in the winter months because it's a little drier in the house, and it does better like that. But yeah, it'll produce little white flowers on it, and it'll produce these long, kind of horn-looking fruit on it.
So I don't have to have two for it to produce the.
No, no. But yeah, they eat the leaves on it. It's supposed to be a very healthy. Right, yeah. Yeah.
Where did you find moringa?
It was a nursery down in Louisiana, and she was going out of business, and it was about this high, and it grows quickly.
Yeah. It's a cool plant.
It's big enough to flower. They call it horseradish tree in India, but it grows in some fairly dry areas, and the roots run out across the ground, kind of like a horseradish tree. Really a bizarre looking plant in the wild, but it's an Old World plant. But yours is big enough to flower. So,
Okay, awesome.
any other indoor?
I've got a yarrow and a buckeye tree.
A yarrow and a buckeye tree. Well, you know the buckeye's poisonous, the fruit. People used to use it for arthritis. They'd take the seed, put it in their pocket, but it does have the saponins in it, which we talked about a little bit, and there are different species of buckeye. Yarrow, been used for like a blood purifier, make a tea out of it. It's pretty pungent. It has some oils in it and stuff, but it'd probably have to be kind of cooked out, heated out. But yeah, it'd be pretty pungent on the yarrow. But yeah, it's been used way back during the apothecaries. Well, millefolium. So Achillea millifolia would be the one I'm talking about, which is the most common one. It comes in pinks and different colors, ornamentals. Typical form is white. So there are some color variants.
The Achillea that you took, the name Achillea, so the genus name on that comes from Achilles. Because they also used to use it to staunch wounds. And so when Achilles got hit in the ankle with the arrow, they pulled it out and they packed his wound with that plant. And so that was named it, that's the story. That's where that name comes from.
Yeah, so you'd see why internally it has some blood activity as well, but yeah.
Putrefying your wounds.
Yeah, and it'd be pretty potent. It's a very strong smell to it. Any others? Any house? Yes?
I pruned back my Spice Island rosemary, and I washed my hands several times, and I can still smell the oils. Tell me about rosemary and what that is.
The linalool oil we were looking at earlier, that's in rosemary. And so it does have the oil in it, which is obviously the one that they get a different species though. It's actually Stochus, which is a lot of times we grow angustifolia, and so there's another species where they get most of the oil of commerce. And so it's a little different species than we typically cultivate. But they both would have the oil in the plant. But yeah, it's an oil. It was something that would probably, sometimes they would use things in tincture, so something that the oil would be solvent in, and so they could isolate it like that in that form. And a lot of those oils were used for distillation, so they would distill it and get the oil out that way. And so there are different ways to get the oil extracted from rosemary. But yeah, it's been widely used. The interesting thing about rosemary, there's a lot of herbs in the Mediterranean, which rosemary is from the Mediterranean, in the Middle East. And so they used a lot of those types of herbs in meats. So this is back before antibiotics and all those kind of things that we do today when we prepare meats, because salmonella poisonings, things like that. Well, what they found with a lot of those, like thyme and rosemary and things like that, is they tend to be antibiotic, okay? And so when they use them with meats, they tend to kind of keep down the food poisoning issue. And so now today we use a lot of that stuff in vegetables and all kinds of things. But back during the apothecary times, they typically used those when they were working with meats, and it was believed to be because they tend to be antibiotic. Yes, ma'am?
Is turmeric as wonderful as everybody says it is?
What?
Turmeric.
The tour?
Turmeric.
Oh, turmeric. Oh, yeah. Yeah, turmeric has some of the same things that the white ginger has in it. So it has some similar chemistry, not the exact same chemistry, but it has some similar chemistry. So yeah, it actually antibiotic would be another one of those. So yeah, turmeric, been around a long time. A lot of praises on turmeric. And of course they cook it. And it's probably going to change a little bit too, depending on how much you heat it and those type things. The pungency, a lot of times they use actually to clear the palate when you're testing different foods and things. But yeah, it'll definitely change kind of the way your taste buds respond. But yeah, it has some compounds in there that are fairly pungent. It's ranked 4 or 5. It has a Scoville ranking actually like pepper, capsicum. So, hot peppers, those type peppers, it actually ranked on the Scoville. So it does have a little bit of heat to it as well if you use it in cooking. But yeah, great plant. And you can go down and you can buy some rhizomes at the store and you can grow those. So easy to acquire that one. Yes, sir.
Oh, I do mushroom therapies.
Mushrooms?
Yeah, and I noticed you didn't touch on it. You didn't touch that.
No, I don't work much with mushrooms. I would hope the pathologist would work more with the mushrooms because they're fungi. I've had calls in the hospital, kids in the hospital, deathly ill. They want to know what the mushroom is, and I don't really mess much with mushrooms. Mushrooms are pretty difficult.
Well, I meant the over-the-counter mushroom therapies. I've been doing them for a year. I really like them. They have for brain, they have for the immune system, and I've experienced positive results.
I can believe it. Yeah, I can believe it. I mean, amanita is one that occurs in mushrooms, psilocybin. I mean, there's some really potent compounds in mushrooms. Those are narcotic, by the way, the two I just mentioned. So that's another reason I don't mess with mushrooms much because, a person get in shelf mushrooms and things like that. Many years ago, I picked some, we took them in, fried them up, cooked them, and they'll greatly elevate your heart rate. And so they look like oyster shells. So there's a case of mistaken identity. Now, I'll eat a lot of different types of mushrooms, but there are a lot of groups of mushrooms that I won't mess with because they get close and they look a lot like something else. I'd rather avoid those. So I don't do a lot of mushroom identification other than just my personal use. But hopefully there's somebody else out there that will do that. Plants is enough. There are about 223,000 flowering plants in the world, about 300,000 overall. So that's the bulk of the flowering plants of the world. So it's a lot of, and you get all the ecology and phytochemistry and all that. It's a lot of science right there. So I kind of stay out of the mushrooms. But I mean, it's interesting. No, there's a lot of different species. But yes,
My dad used to eat poke salad.
right?
And he would boil it and boil it and boil it. And
Exactly.
all that up.
Yeah.
Why?
Calcium oxalate. Yes, it's poisonous. Yep. So, yeah, you can get too much, particularly if it turns a little bit red color. Same way with rhubarb. And so that's why they blanched it, so they would put something around it to keep the light off of it because it'll be produced exposure to light in the plant. And so if you get that reddish color, start to form that red color, yeah, you probably stay away from that. And you still need to parboil it. So, but yeah, I mean, the thing about poke is you can get some pretty big, if they're big plants, you get some pretty big, shoots out of that. But you got to get them really early, before they start to color up and leaf out. So yeah, timing is really important on those. But yeah, calcium oxalate can be poison. Calcium oxalate's formed, sometimes you get it in the soluble form, and then sometimes you get it in the crystalline form. In the case of Araceae, and those are rhaphide crystals. Dumb cane, that's a rhaphide crystal of calcium oxalate. So that's a whole different reaction. It's a physical reaction that can cause suffocation if you consume much of it without cooking it thoroughly. So, yes?
Can you talk about the conservation issues with ginseng just a little bit? Do you know how am I putting on? I don't think that's
No.
but you
No.
mentioned it.
No, I worked a number of years with TVA, and that's what we did,
Okay.
Heritage.
Okay,
Yeah,
all
so I
right.
worked with Heritage, yeah,
Yeah.
on environmental impact statements and things like that. And ginseng was on a bunch of state lists.
Sure.
It's on Tennessee as exploited, commercially exploited, and so it's protected. In Mississippi, it's listed as threatened, so it's on our rare plant list for the state list. It's not federally protected, so it's not on the federal list, but it is on a number of state lists. So if you do NEPA, environmental impact statements, that usually shows up on there. If it's an S1, it's pretty significant. So it might reroute a power line, something like that, because of its existence there. The wild one is certainly far more valuable. I don't know what it is now. It used to be like $400-something a pound. It is commercially produced. The leading states, I think it's like Missouri, Illinois, some of those states up there. So they do produce it commercially, which takes a little bit of pressure off of that, but it doesn't bring near the value that it does in the wild. And so that's why they have the TV show, it was the Ginseng Wars or whatever out in the Appalachians. So, but yeah, because of the value of the plant. But it is protected, and I suspect that it probably has some root associates, mycorrhizae or bacteria that might be somewhat responsible for part of that. I don't know, but it needs to be done. The work does. So. Any more questions? There's 400 something. We got a lot of species on our state list. So a lot of people think of the federal list, but we have state list as well. Out of Jackson, heritage programs. Each state has a heritage program, and they keep track of their list of rare species. And a lot of our medicinal plants would be on that. Golden seal, black cohosh, ginseng would be on there. Polyphenols not, it's a little more common. Cypripedium would be on that list. So there's a whole host of those medicinal plants that would be on that rare plant list. Yes?
How much does, I think I know the answer to this, but how much in the preparation of a medicinal herb, heat plays a lot, makes a huge change in how it's prepared, whether it's microseeds.
It does. It does. Yeah, depending on the compound. And some they do in tincture because it's an oil and it's kind of a little bit difficult. But with enough heat, you can get an oil out, right? Because that's how they use distillations. So yeah, you could do that. There's decoctions and infusions and tinctures, and so those are the three major ones. You know, one you pour it on, you know, hot. The other one you boil it while it's in there, and then you have a tincture. Use alcohol to bring it out. So those are the three common ones. Of course, we drink, you know, coffee, and you know, so we're already doing some of that already with coffee and tea. But yeah, it does make a difference. It depends upon the compound. A little bit of the chemistry of the compound, if it's an oil or it's, you know, if it's water soluble.
And just briefly, is it like if you took a raw leaf of tobacco and put it on your skin, it would cause an ulcer? Wet tobacco.
Could do it.
Yeah.
Yeah, it could cause some problems. Yeah, there's a number of plants that are caustic, and so they'll blister you. Euphorbs are classic examples of those. Sometimes they actually burn your eyes. They're so caustic just in the air. But yeah, that's, of course, you got some things that cause, you know, your photo problems. If you get the plant on you, it actually ruptures the cells. It's reactive to light, and it'll cause a cell rupture process to lead to blistering. So hogweed, which is one been in the news lately, is one of those that will cause that.
I have a question. Do you find that the essential oils, that the compounds, are they basically the same as what you would get from the live plant? Like, you know, people are big into essential oils nowadays. Do you find it to be compatible, I guess is the word I'm looking for, with what you get?
It'd be the same, right? It'd be the same thing. It's just, it's.
The compound would be the same.
That's right. It's just in concentrated form, so you have to keep that in mind. You already distilled it and you've concentrated it in a little vial. And so the one thing about essential oils, a lot of times you can smell it. Like you mentioned lavender earlier, you can smell it and you know it's in there. So that's a little bit different than these because you can't always smell it, so you don't know if it's in there or not. But yeah, with essential oils, but you just have to keep in mind that it is a concentrated form, so you're not going to use as much of it. Because usually in plants, it's a small fraction of the overall chemistry of that plant. And so if you're using it like you were talking about in a tea or whatever, if you're using the actual plant, you may need to use a little more than what you would be with the purified oil. But keep in mind too that those oils, the essential oils, sometimes have multiple compounds. not just one compound. Remember I mentioned turpentine, pinene is the major one in there, but there are other compounds in there. And they may have a little different bioactivity.
Is it one of the criticisms of essential oils is it's put a stress on the availability of the vibrancy of those plants, like, say, I don't know which particular ones, but it takes so many pounds of a certain flower to create this oil, and so therefore you're using up that as a resource, as an available resource.
So you're...
I'm just saying, it's something I read, it's like it's put a stress on the availability.
You mean like making them rare or something other than wild collection? Yeah, and we were talking about a number of species on our state list are actually listed as rare. Now part of it's because they're in the southern part of their range, but again, there would be some issues with over collecting on those plants. Yeah, you could run into some problems. And that's a problem with wild collecting, and I guess in general, unless it's just really, really common. But you got to kind of know that, right? Mississippi Museum of Natural Sciences. That's where you'll find the list. So they'll have the state list. You go on the web, you can find it, and you'll see a whole myriad of plants. A lot of those are medicinal, have some ethnobotanical use, something like that. But they would be a pretty extensive list for the state. So, but they're not all rare because of the over collecting and all that. Sometimes habitat loss. Humans are number one threat to rare and endangered species. Number two threat, what do you think? Invasive species. Number two threat. 42% of all rare and endangered plants are threatened by invasive species. So, I mean, that's mostly a result of us, but bringing them over here and them getting loose. But yeah, those are the two major threats. So that kind of give you an idea of kind of why some of those things are listed. All right.
Any other questions? All right. Let's give Victor a hand. Thank you very much.